Welcome to a lesson with Dr. Powell. Let's look at a way that we can find the volume of a geometric solid if we know what the derivative of volume is. How do we know what the derivative of volume is? Well, maybe it's given to us. Maybe we understand that the cross sections, if we cross cut with respect to a variable, have a certain shape. In this particular case, let's suppose that we're given to know that this is kind of even like a loaf of bread and we're taking slices, but kind of a wedge type thing. And we know that the cross section pieces are squares. Knowing what the cross sections are tells us precisely what the volume is with respect to x, volume growth going this way. And up to this point, the volume up to this point, the volume up to that point, and so forth. Kind of looking like this, thinking of going up. And what we're given to know is we know what the base of the shape looks like, and it lives in the xy plane, and then we're given cross sections which come up from there. Now here's another picture of what we're looking at. So we have the curve y equals square root of x, and we're just going from 0 up to 1. Okay, so that's what it looks like. Now, so how do you find volume? Well, you need to find the change of the volume function if we go from 0 to 1. And to do that, we take the integral of the derivative of the volume. The derivative of the volume is precisely just that, the area of the cross section. Now, what's the area of a cross section at a particular position x? Notice that these cross-sectional areas are changing as x moves. So what we do is we pick an arbitrary x location and we examine it. It's going to be different for each one along the way. So we just let x represent a representative one just somewhere in the middle. So we take x and we see what the lengths are. Now we know this function is y equals square root of x, which means at x, the y value to get from here to here is square root of x. Well, that's precisely the base of the square. So square root of x. So just taking this cross section, looking like this, the base is square root of x and the top is up and down is square root of x. So multiply together to give you area is just x. So that means the derivative of volume growth is just the area of this cross section, which is just x itself. So to find the volume change from 0 to 1, which is precisely just v of 1, since v of 0 is 0, we take the integral from 0 to 1 of x dx. X is the derivative of volume growth with respect to x going this way. And evaluating this integral, we get 1/2 as the volume. Thanks for watching.